The definition trap. Let's start with a wagon. A simple red wagon. Inside, there's a ball sitting in the corner. You pull the handle. The wagon moves forward. The ball rolls backward. Why, if you ask a high school physics teacher, they will smile comfortably. They will say, that is inertia. They will turn to the chalkboard and write a formula. F equals ma. They will recite Newton's first law. An object at rest tends to stay at rest. You will write this down in your notebook. You will memorize it. You will pass the test, and you will think you understand physics. But you don't. You have been tricked. You learn a word, not a reason. Richard Feynman knew this before he could even solve a calculus equation. When he was a child, his father told him the truth about that wagon. He said, Richard, the general principle is that things which are moving tend to keep moving, and things which are standing still tend to stand still, unless you push on them hard. This is called inertia, but nobody knows why it is true. This is the distinction that separates a genius from a student. Most people think that naming a phenomenon is the same as explaining it. It isn't. If I tell you that a bird is a brown-throated thrush, I have told you absolutely nothing about the bird. I haven't told you how it flies, why it sings, or where it migrates. I have only told you what humans call it. Inertia is just a label. It is a fancy word for stubbornness. It is a linguistic placeholder we use to cover up a gaping hole in our understanding of the universe. When you push a heavy rock, it pushes back. Why? The standard answer is mass, so it has inertia. But this is circular logic. What is mass? It's the measure of inertia. What is inertia? It's the resistance caused by mass. You are trapped in a loop of definitions that explain nothing. Stop looking at the equations for a second and look at the reality. This is actually a terrifying mystery. Imagine you are in deep space, absolute void, no planets, no air, no friction. You are floating next to a massive spacecraft. It is weightless, but if you try to push it, it resists, it fights you. Why? There is nothing touching it. There is no air to push against. There is no gravity holding it down. Yet, when you apply force, the universe demands attacks. It demands energy to change the state of that object. What is mediating that transaction? How does the rock know it is moving? If you are inside a windowless room on a spaceship, and the spaceship accelerates, you feel it. You are pushed into your seat. But how does your body know? How does the biology of your inner ear know that the ship is moving if there is no window to look out of? The atoms in your body are reacting to a change in motion relative to what the standard textbook answer implies, that space itself is a grid, a fixed stage, and objects resist moving across that stage. But Feynman didn't like that answer. He knew that the label inertia was hiding a much darker, more complex relationship. He suspected that the resistance you feel when you push a wagon isn't coming from the wagon at all. It's coming from somewhere else. To understand why the ball rolls to the back of the wagon, we have to stop looking at the ball. We have to stop looking at the earth. We have to look at something much, much bigger. We have to realize that the inertia you feel in your hand is actually a ghost. It is a phantom force reaching out from the furthest edges of the cosmos to hold your hand in place. The lie is that inertia is local. The truth is that it is universal. And to see it, you need to make yourself dizzy. The cosmic connections stand up. Right now, find a clear spot in the room. Make sure you won't hit anything. Now spin around in a circle as fast as you can. Feel that. Feel the blood rushing to your fingertips. Feel your arms lifting up, pulling away from your body, fighting to stretch outward. You have felt this 1,000 times since you were a child. We call it centrifugal force. It is the most mundane physical sensation in the world. But stop spinning for a second, let the dizziness fade, and ask yourself a question that will absolutely break your brain. What are you spinning relative to? You might say, I am spinning relative to the floor. Okay, let's remove the floor. Imagine you are floating in deep space. You spin. Your arms still pull outward. You feel the tension in your shoulders. You might say, I am spinning relative to the Sunday. Okay? Delete the Sunday. Delete the Earth. Delete the Milky Way. Now we arrive at the most disturbing thought experiment in the history of physics. Imagine a universe that is completely empty. No stars, no galaxies, no gas clouds, just you floating in an infinite black void. Now spin. If you spin in a completely empty universe, do your arms still pull outward? Think about it. In an empty universe, there are no landmarks. There is no left or right. There is no clockwise or counter-clockwise. If you are the only object in existence, rotation has no meaning. You cannot rotate relative to nothing. If you are the only thing there, you are arguably always stationary. So if rotation is meaningless, then the force that pulls your arms outward should vanish. In a truly empty universe, you could spin 1,000 times a second, and you would feel nothing. No dizziness, no force. Your arms would drift loosely at your sides. The concept of spinning would cease to exist. But here is the horror. We do not live in an empty universe. When you spin in your living room, your arms do pull outward. The force is real. It is violent. It wants to tear your muscles apart. Why? Because the universe is not empty. When you spin, you are not spinning relative to the carpet or the walls. You are spinning relative to the fixed stars. You are spinning relative to the distant galaxies, billions of light years away. This is the mind-bending proposal known as Mach's principle, named after Ernst Mach, a physicist who deeply influenced Einstein. Mach suggested that inertia, that resistance you feel, that heaviness, that centrifugal force, is not a property of you. It is a relationship between you and the rest of the universe. When you spin, your arms are being pulled by the gravitational influence of every single star, planet, and black hole in the cosmos. The atoms in your fingertips are communicating with the atoms in the Andromeda galaxy. They are locked in a gravitational dance. The reason you feel a force is that you are rotating against the background of the entire universe. The universe is holding you still, and you are fighting it. This changes the entire feeling of reality. Think about stumbling on a subway train. The train stops abruptly, and you fall forward. You blame momentum. You blame inertia. But what actually happened? The train stopped. Your body wanted to keep moving. Why? Because your body is gravitationally locked to the distant stars. The train tried to change your motion, but the universe said, "Number." The universe holds you in place. The pull of 1 trillion galaxies keeps you moving forward, and that cosmic grip is so strong that it throws you off your balance. You are not an isolated entity moving through empty space. You are a puppet, and the strings are infinite, reaching out to the edge of the visible cosmos. Every time you feel weight, every time you feel resistance, every time you push a door open, you are feeling the weight of the universe pushing back. This sounds like magic. It sounds like astrology. How can a star 1 billion light years away have any effect on your balance? It seems impossible. And because it seems impossible, schools don't teach it. They teach you something safer. They teach you a lie about a field that doesn't exist, just so you don't have to think about the terrifying interconnectedness of all things.